Okay, we're back now for the third lesson in our unit, which is right angle triangles, but also is kind of interchangeably called trigonometry. And what we're going to do now is introduce the topic of trigonometry. It's actually one of my favorites. I enjoyed learning this, and it's something that I remember right from high school myself, and many of my friends use it in their various occupations, so it certainly is a useful skill. Now, and I guess if you look here at the very front, trigonometry, engineering, architecture, surveying, aviation, navigation, carpentry, forestry, it goes on forever and ever, okay? Now, trigonometry means triangle measurements. Now, in the previous video, we covered Pythagoras' theorem. Now, remember, Pythagoras' theorem works when you have a right angle triangle and you are given two of the sides. If you are given two of the sides, you have the ability to find the third side. As a recap on this one, you would go c squared equals a squared plus b squared. And remember, this is the formula that we use when we are looking for the hypotenuse. As a quick summary, 5 squared plus 4 squared. C squared equals 25 plus 16. Pardon me, I'm out of room. I'll go up here. C squared equals, what is that, 41. And you're going to have to square root both sides. And that's going to give you, I will just use my calculator here for I don't say something wrong while I'm being recorded, I guess. And that's going to give you about 6.4. Recall there was another situation where you can use Pythagoras' theorem when you are given the hypotenuse. Let's go, I don't know, 10. And you want another side. So in this case, we do have a missing side, but we have the hypotenuse. So remember, we use this form, b equals c squared minus a squared, b squared equals 10 squared minus 7 squared. Sorry, I'm out of room here. B squared equals 100 minus 49. And if I just, I guess I can erase this now because you guys can go back and forth and rewatch everything and rewind. So if I go here, I'll just shoot to this side. That's going to give you b squared equals, what is that, 51. Square root both sides. B would be equal to square root 51, about 7.14. Okay, so the next step is, what the heck happens when you're not given two sides and you want to find other things in the triangle? And that's when we come to trigonometry. So in trigonometry, before we really get into the calculations, what you have to do is understand some terminology. And it's under fact 8. In trigonometry, there are two other sides that we haven't talked about yet. They are called opposite and adjacent. And they're not consistent. I'm going to tell you that right now. They change. The only side or the naming that never changes is the hypotenuse. Remember, the hypotenuse is always opposite of the 90-degree angle. It all depends on the angle we are given. So if you look at this example right here, this is your 90-degree angle. Therefore, by default, we know where our hypotenuse is. When we do trigonometry, you will either be given an angle or asked to find one. Now, this is an angle symbol, so they're drawing your attention there. From this angle, we have to name our other two sides, and they are opposite and adjacent. When you look now at the angle we are using in our question, which is this one, the side that is across from it is always the opposite. So you see, you now have kind of 2/3 done. You're always going to know where the hypotenuse is because of where the 90-degree angle. All you have to do, find the 90, go across, boom, hypotenuse. Using the same logic, find the angle in our question, go to the opposite side, that's opposite. By default then, there's only one side left, and that always has to be the adjacent. Let me give you another example. Or pardon me. Well, yeah, I'll give you another example. I'm going to leave this one alone for right now. Let me just draw this out. Okay, so let's say we're looking at this angle right here. Let's name our sides. So the first thing you do is you find your 90-degree angle. Here it is right here. We go across. We know that is our hypotenuse. Feel free just to use an H. The next one you always want to label is your opposite. Find the angle in question, which in this case is right here. The side across is always going to be your opposite. By default, what do we have left? We have adjacent. Feel free to use a capital A. That's very important. I know this is a very small lesson with, very little to go over, but the point is, it's crucial that we name these properly, because when we get into what's called sine and cosine and tan in the next few lessons, if we can't do this properly, we're going to be in deep trouble. Now, you'll notice that I said that we were going to come back to this original drawing, or I guess it's not really my drawing. And I wanted to say something to you here. It's very interesting. You can see where everything is labeled. You can see that you have D, E, and F. And what I'm going to do is I'm going to leave this as D. I'm going to leave this as E, and I'm going to leave this as F. Now, this is a 90-degree angle. So right away, yep, here's our hypotenuse. But what if we're not dealing with this angle anymore? What if we're dealing with this angle up here? As I said to you earlier, the opposite and adjacent are not consistent, because you see, now we're worried about this angle. Therefore, this is now your opposite side. Or sorry, I should be consistent. We'll just use O. By default, this is A. Okay? So the point is, the hypotenuse always stays the same. But depending on the angle that you are using, the opposite and adjacent can change. If we just go a little bit further here to the next page, if we look at example, it went a little bit too far. Example 1, it says, number 1, what is the hypotenuse, or as in what's the length? Well, there's your 90, go across, it's 15. Number 2, what is the opposite side to, well, the angle symbol? Well, here's your angle symbol. Go across, it's 9. What is the adjacent side? Well, if you follow my logic, we figured out this was the hypotenuse. We figured out this was the opposite. By default, adjacent, so that must be 12. Oh, look at this. This is awesome. Same triangle, they just changed where the angle was. So what is the hypotenuse? Nothing changed. Got to be opposite of the 90. There's your 15. What is the opposite side to the angle? You see it changed. Here's our angle. Now this is our opposite. It's 12. So this would be your hypotenuse, your opposite, your adjacent, 9. See that, everyone? Up here, look at where the O and the A is. Come down here. It's changed. Ask yourself, why did that happen? It happened because of where the angle we're using is. Okay, it's very, very crucial that you have the ability to be given any triangle. I put the angle symbol here. Let's label. Here's my 90, or right across must be my hypotenuse. Find the angle in question, go across. That's your opposite. By default, that's your adjacent. If I keep that same triangle, but I now move the angle in question down here, let's list off the sides. This didn't change. That's your hypotenuse. The side across from the angle in question is always your opposite. By default, this will now be your adjacent. That is really, really important. I would ask you that you try the practice questions. Ensure that you get them. If you don't, watch this video again or ask your teacher. It is so crucial that you are able to properly name, well, the hypotenuse, the opposite, and adjacent of any triangle.